About 6 months ago, I made a video where I ranked approximations of pi. I ranked them based on how interesting I found their mathematical structure to be, as well as their accuracy and historical significance. But a lot of people pointed out that the tier list should be ranking based on how useful the approximations are. And looking back, I completely agree. While of course people are going to have different opinions on a topic like this, it was a genuine pleasure to read through all the comments and learn just how many other people have such strong opinions about math and pi approximations as myself. So this time, I'll be ranking primarily based on usefulness and practicality. And then I'll give some weight to mathematical structure, historical significance, and just whether or not I like it. 3. S tier. You have a pizza 8 inches across, it's about 24 inches around. Easy math. That's a nice approximation right there. 1, 10, and 5 all go in B tier. While doing rough estimations in physics or math or whatever else, you often care about powers of 10 and scaling laws and proportionality. So while these numbers are not very accurate approximations, they're at least pretty good for mental math. Akira Haraguchi is not an approximation of pi. He is a man who holds the unofficial record for the most digits of pi recited from memory. It's a bit difficult to rank Akira next to other approximations, but he seems like a nice guy, so he gets a spot in S tier. There are also a few other people with official records around 70,000 digits. Let's say they're all S tier as well. And here's a list of those official record holders if you're interested. Square root 3 plus square root 2 isn't all that practical in terms of mental calculations, but I placed it in C tier because it's easy enough to remember, and there's a really nice way to visualize it geometrically. Take a unit circle O and draw a horizontal line across it. Create this triangle with hypotenuse square root 2, and this triangle with hypotenuse square root 3. Divide each hypotenuse into 4 equal parts. And then use these segments to create circles A and C of radius square root 2 over 4 and square root 3 over 4, respectively. Chaining congruent circles together, we end up with points B' and D'. If we connect B' and D' with this red line, it really looks like the red line is perpendicular to line AC. But is it? Well, no. If we get rid of all this extra stuff, flip the green line, and zoom in, we see the green and blue lines overlap a bit. Which makes sense because square root 3 plus square root 2 is slightly larger than pi. Another C tier approximation is 9 over 5 plus square root 9 over 5, which is our first in the list either directly from Ramanujan or influenced by his work. This approximation, along with square root 3 plus square root 2, has a problem that a lot of others will see on this list. That is, if you're going for practicality, why not just remember the first 3 or 4 digits of pi? Or better yet, just use a fraction or a whole number. I can't imagine it's really any easier to have to deal with the square root of 5, whether doing math mentally or by hand. The colliding blocks approximation goes in E tier. While this approximation is entirely impractical, it still has to go in at least E tier because it's just so cool. I'm not going to go over it here, but 3 Blue 1 Brown has a great video on it that I'll link to in the description. Next is 3.14. Is it the most practical approximation on the list? Not really. If you're doing some quick mental math, you should probably just use the number 3, and if you really need some accuracy, you might be better off just using a fraction. But 3.14 still goes in A tier because it's the default approximation most people think of. And here's a fun bit of history. Back in 263 CE, the Chinese mathematician Liu Hui found pi to be somewhere between these two numbers, so about 3.14. He did this by inscribing a circle with a 96 gon and a 192 gon. To see how this works, consider a unit circle inscribed by a yellow polygon with n sides, in this case 6, and a green polygon with 2 end sides. We call the yellow area A sub n, and the yellow area plus the green area A sub 2n, so the green area alone is the difference between the two, which we denote d sub 2n. The red area is equal to the green area, so the combined yellow, green, and red area is a sub 2n plus d sub 2n. This tells us that the area of the circle is between a sub 2n and a sub 2n plus d sub 2n. The area of a unit circle is pi, so this algorithm gives us a range for the value of pi. Another important detail: if you flip 3.14 across its vertical axis, it looks like it spells PIE, which is objectively the best argument for it. This approximation can be attributed to Archimedes, and it was found in a similar manner. He inscribed and circumscribed a circle with regular polygons of the same number of sides, giving an upper and lower bound for the circumference of the circle. You may have noticed that 3 1/7 is 22 over 7, so we have Archimedes to thank for that one as well. This next approximation is kind of pretty looking with all the fancy constants and whatnot, but I'm making it a rule that anything that uses irrational numbers to approximate pi goes in F tier. And I'll just go ahead and finish up F tier with all of these approximations. This approximation comes from an equation similar to the one used to derive 9 over 5 plus root 9 over 5. I feel it earns a spot in C tier as well. This one is known as Kochansky's approximation. It was published in 1685, and it has a pretty interesting derivation you can do with just a ruler and a compass. This construction produces a right triangle with hypotenuse CL, which roughly traces out 1/2 circumference of unit circle A. The point of the extra geometry is to reliably produce side FL of the triangle with side length 3 minus root 3 over 3. So you get 5 digits of pi from a nice drawing with minimal technology, which is great, but again, not very practical. 22 over 7 goes in S tier. 355 over 113 is notable because it's one of the few approximations in this list that approximate more digits than the number of digits in the approximation. These last two approximations are both best rational approximations of pi, essentially meaning you can't find a closer fraction without using a larger denominator. There are infinitely many best rational approximations of pi, and I'm just going to throw the rest in A tier because they're not quite as famous as 22 over 7 or 355 over 113. You can calculate a best rational approximation of an irrational number using continued fractions like this, plugging in more and more values to get a better approximation. In the case of pi, the terms A0, A1, A2, and so on look like this. 223 over 71 is the other mixed number in the A-tier approximation by Archimedes. It's not a best rational approximation and not used all that commonly, but it's historically significant and fairly practical, so it goes in A-tier. 25 over 8 goes in A-tier as well. 377 over 120 was founded by Ptolemy in the 2nd century CE. It's the first known approximation accurate to 4 digits of pi. The approximation is the median fraction of 22 over 7 and 355 over 113. This one is a bit cumbersome, not extraordinarily accurate, so it goes in E tier. This D tier approximation comes from this series from the Kochansky brothers, which is a slight variation on similar series developed by Ramanujan. Series like these are used to reach records for computing the most digits of pi. Speaking of which, in December 2025, the team at Storage Review broke the record for the most digits of pi calculated. They did this using a program called Y-Cruncher, and they go in S tier because 314 trillion is a really big number. This next approximation in C tier is the first term in this series by Ramanujan. This series adds an extra 8 decimal places of pi with each successive term, whereas the Kochansky series mentioned earlier adds about 14 decimal places per term. This approximation is just a random coincidence and probably not all that fun to work with, but at least it doesn't have any square roots, so B tier. Buffon's needle is a pretty fascinating way of approximating pi. Draw some parallel lines separated by length d. If we drop a bunch of needles of length L, where L is less than or equal to d, then the probability of a needle crossing a line is 2L over pi times d. Rearranging, we get that pi is approximately 2L over p times d, which can be rewritten like this. And if L equals d, then this approximation simplifies quite nicely. In the example on screen, we get that pi is about 3.2. Knocking out a few more approximations from Ramanujan, this ridiculous-looking thing is good for 53 digits of pi. And so is this one. And this one is good for 31 digits. There was once a man so certain that pi is equal to 3.2, he proposed the Indiana Pi Bill to turn this assertion into mathematical law. But he was wrong, and the bill didn't pass. 4 goes in A tier as well, but I don't really know why you'd use 4 over 3. That's just kinda silly. At least 1, 10, and 5 gave you nice round numbers. But whatever. This D tier approximation is another example of one that has been engineered to be close to pi. 1 over pi to the 193rd power is this number, and we can change the 5 to a 2 to make it look a little better. Let's truncate this decimal to make this an approximation, and we can denote the decimal as a to help with manipulation. And from here, I'll just quickly show you how the math works out. Circumference over diameter is an obvious candidate for S tier, and this fun little approximation goes in C tier. The next 4 approximations were all recommended by commenters, and they all go in B tier. They would probably go in C tier, but I'm running out of room. This one seems like quite a bit of work for just 6 digits of pi. It comes from Viet's formula, which was published in 1593 and was the first formula of European mathematics to represent an infinite process. This one is from Ramanujan, and these two are just random. And the square root of 10 goes in B tier. I guess this one is a pretty neat coincidence, but really it's about as useless as it gets. You might look at this one and think, wow, that's a lot of digits. Also, what's that U doing there? Well, in this approximation, U is defined like this, where A, B, C, and D are defined like this. So yeah, good luck using that on your next math test. And finally, square root G goes in S tier. A few people pointed out to me in my last video that the meter was almost defined such that square root G was exactly equal to pi. We take the small angle approximation for the period of a pendulum and solve it for square root G. A meter was almost defined as the length of a pendulum with a period of 2 seconds. So plugging in L equals 1 and T equals 2 gives that the square root of G equals pi. This definition was rejected because the period of a pendulum with this length would vary based on geographical location. And that's it, that's the tier list. If you enjoyed it, please like and subscribe, and thank you for watching.